This presentation is an overview of the project that I worked on for CSCIE222, a workflow for in silico truth data generation and evaluation for RAG models. The motivation for this project was that I was hoping to work with RAG models, but I found that it was difficult to find gold standard or labeled data to work with. And so in looking around, I found a workflow for the ability to create labeled data from unlabeled data and work with RAG models. And so I wanted to set that up. And so here I will demonstrate the experience of setting that up today. So at a high level, there is a portal that I was hoping to add a query to that would be based on a RAG model, having a RAG model behind it. And that portal has publications associated with it, and I would want to be able to query and answer based off the publications associated with that portal. And that portal can have publications added to it or removed in a self-service way. So it's a dynamic space, making a RAG model just a really, really nice thing to use. And so how, sort of like the big idea on how to this project approach things was that number one, the portal, I used the APIs to get access to metadata around the publications, and that included URI. Using those URIs, I downloaded publications and extracted the abstracts and the introductions for this project, and then ingested those into this case here, a RAG model. And so they were ingested into my database. So with that, and had a whole bunch of chunks at that point that were in embedded space, and then I took those and sent the chunks to a separate model, and that model created question and answer pairs with a separate prompt. And so those question and answer pairs then sort of became gold standard labeled data for me. They were easy, medium, and hard depending upon the question. So there was 3 question answer pairs per chunk. Those were stored back into the vector DB. Since then I now had questions, then I could enter those questions into the RAG-DB, and that would allow me to not only evaluate the retrieval, but also would allow the RAG to generate an answer. And so with that, I ended up having the question answer pairs and also the RAG answer as well. And I sent that to another separate model, and that judged how well the RAG model did with its answer. That prompt was engineered in a way where the model returned metrics on overall, which was a combination of the specific metrics and also hallucination, accuracy, relevance, and completeness, as well as giving a text justification on why it assigned things as it did, moving from 1 to 5, from easy to, it's from the worst to best. So that was the general idea, be able to ingest data, have a RAG, be able to generate question and answer pairs that were sort of labeled for me and varied in difficulty, have the RAG to answer, and have something to judge it at scale. As far as the technology that was used in this project, as far as the APIs go, I just used standard Python to access the APIs. Pulling text from the publications was a manual process currently. The ingestion pipeline itself was in Python and was a lot of the tricks and code that we used in class. The RAG-DB itself was a Lance DB for the actual database, and Lance DB was awesome. I highly recommend it. As far as the embedding model goes, this is the embedding model that I used. It was small and it was quick. It was what I needed. And then for the actual generate step, I used Gemma 3, which had a larger context space and was more appropriate for the question answer kinds of things that I needed for this. And so as well, separately, there was one prompt here, there's a separate prompt here, and another prompt here, but all of them were using Gemma 3 as far as the model goes behind the scenes. Throughout this process, there were spaces where there were visualizations that were created, and those were using standard Python visualization and data science kits. As far as the ingestion, diving a little more deeply into that, number one, the APIs that I use for the portal, single cell portal is the portal that I was working with, are public APIs, and so I was able to grab that and then extract text and did the extraction with in a manual way. This was a little difficult because of paywalls, but was able to grab enough information and text for the project. As far as cleaning data goes, I did what we typically did in class, so that was the removing HTML, Unicode, emojis, normalizing space and punctuation. I also was able to find a nice way of creating chunks of 1,000 characters with 100 character overlaps. That worked quite well. And I programmatically defined the LansDB table schema that's in the notebook that's included for this project. And with that was able to ingest the chunks into the LansDB, which automatically generated embeddings using the embedded model for me. So after the chunks were in the database, I was able to use a separate outside model to generate question and answer pairs, as I mentioned before, for each of the different chunks. So with that, then I ended up having a chunk, a question, and an answer all together in the database, and that enabled me to look at the retrieval a little bit. So given the RAG and the question, I could see if the chunk that was associated came out with the retrieval and at what rank it was. And so the actual retrieval step itself currently for the configuration I have uses approximate nearest neighbors, uses about 10 items in the retrieval, 10 chunks in the retrieval, and L2 Euclidean search, which could be potentially looked at and optimized. The cluster, I also clustered the embeddings themselves and used k-means to create some labels, as well as used CSCIE to create a 2D ordination that I'll show you when looking at the retrieval piece. So as an example of some of the things that one can do with the information that I had at the point of retrieval are shown here. Number one, this is a two-dimensional ordination of different chunks. So each point is a chunk in the embedding space. As you can see, there's a lot of hard clusters here, and those hard clusters are mostly document IDs, and so it seems very topical how it's clustering things. This is painted or labeled by the document IDs. I did paint it and labeled it by k-means clustering as well. It was not as helpful. I continued to use document IDs moving forward after this because it seemed to be the right structure. Here I have just a standard histogram of the rank of chunks during the retrieval step. So for instance here, this is the count of how many retrievals had the correct chunk in the first rank up first in the retrieval. And so better to worse, but nonetheless, if something was retrieved, it was retrieved within the first 10 typically, and so that's why that setting comes from that I mentioned earlier. Over here on the right are some more CSCIEs, and you'll see a lot of these CSCIEs. And the reason, even though the background's slightly different, it's mostly the same plot. The reason why I will use these is you'll see, for instance, I'm looking at, given the retrieval, what was the rank of the retrieval, given it was easy question or it was a hard question, for instance. And I'm looking to see if there's any localization of color, like a lot of red here, for instance. It might indicate that there is a local problem with a specific document. And not seeing it here at all for those, and so that's generally good. So after looking at the retrieval for a little bit, I was able to also start evaluating the answers that were given. So once again, the question was given to the RAG. That was a part of the question answer pair. The RAG now gives an answer after that retrieval. So the retrieval was the 10 retrieved chunks were concatenated as part of a context for a generate step in the RAG. And so at that point, I have a RAG answer. Using the question, the answer that were labeled and generated for me previously, and then the RAG answer, I was able to give this to another now separate model that was prompted to be an expert virtual judge. And it returned 5 different metrics, giving quantitative measurements from 1 to 5, worst to best, and giving a rationale. And so now my database has the following full data set for each chunk. It has its ID, has a difficulty of the question, and remember there's 3 questions per chunk. It has these different metrics that was mentioned here that were given back from the judge, the chunk itself, the question answer pair is in here, question answer, the RAG answer itself, and the justification on why these were given. So it's a really nice data set to start looking at things. And looking at the generate step now, there's a couple plots that I used for that. Um, these are the metrics that were returned, and they are stratified by the questions if they were easy, medium, or hard. So say for instance in this case here, this is the overall metric that combines all the metrics, and 5 is like the best. This is the good side here. And so typically for an easy question, it is a central tendency to do really good, and medium as well, but as far as hard goes, there's more of a central tendency to be at 4, which is a little worse than 5. And so what we're seeing here is that the harder questions were a little harder, but in general they were still doing okay. Certainly is a space to look at to optimize though. And so you see sort of that same for factual accuracies, or see that same trend as well. For relevance, this is an interesting one. You see like things are highly relevant, or there's some noise, looks like, for the most part. So it'd be interesting to look and see what's creating that noise, for instance. Hallucination and completeness have this central tendency out, like have this these little bit of a, I don't know if that's bimodal or not, but there's a little bit of a tendency here at least to not be at the top, and so those are likely driving this tendency to be at 4, for instance. And looking at the T-SNE, here we have a T-SNE looking at the hard questions. Of the hard questions, what was the overall answer? So overall, how well did the RAG do with the hard questions? And there's no real central, once again, localization of any cluster colors enriching certain areas and stuff like that. So no particular thing there. And so that it sort of ends up the workflow that I was hoping to put together, and that will enable me to continue working with the RAG and being able to configure it and update it and such. So the pros for where I'm at now on the project is, number one, this is fully automated, which is really cool, and it does allow me to make labeled data and work with labeled data, and it easily scales. So those are really nice, and that was the point. So I think like well done as far as that goes. As far as the cons goes, number one, just specifically the data that I'm working with, the publications, they're very heterogeneous. The structure is like they're structured, but nonetheless, like you can get all sorts of formats, and so they're a little difficult to work with. This does require humans to interpret the evaluation data, so like even though it can be done end to end in an automated way, you still need humans to look at the graphs and say, oh, okay, the RAG's doing well or worse, we should configure it this way or that. I mean, you could imagine another layer being put on top of it that could do that as well, and like gradient search within some configuration space or something, which would be interesting, but is not done. And then some of the metrics, I believe, can be thrown off by just other chunks that are highly correlated to the chunk you're wanting coming into play, and sort of confusing the answer a little bit. So for future work for this project, number one, working with the APIs fully, so there's no manual step, and getting publications through the URI that I'm getting from the metadata, like in a programmatic way. Also using libraries to parse publications, there's a couple out there, and do more structured parsing of them, and then being able to pull in metadata, like this is a chunk from results, for instance, or discussion, or whatever it might be, and then measure and see which parts of publications are most often used to answer questions people are having. I think that'd be interesting. I mentioned earlier, high similarity chunks can throw off the retrieval and generation metrics, and so maybe trying to understand how I could work with the correlated items a little better. This, of course, is set up and ready to go to be able to compare performance of different models and switching them out, or configurations of the RAG, and so that would be fun to do as well. And lastly, of course, once that has happened, bringing a RAG model into the portal itself as behind a query. So this work is based off of a lot of great things, and some of that is from our class, and then other are from some resources online. So I wanted to make sure that people were aware of those resources. Number one, to give them citing and credit, but also for you to check them out. These are really great YouTube series, and I highly recommend them. As well, I did use some cleaning code from class, and the chunking code I found here, which worked really well, and I would recommend you to check it out. Thank you so much for your time.